Hi, in this lesson we want to cover cyclic quadrilaterals, but before we do, I just want to cover one more circle law that was not covered in the previous video. So this law states that if we have a chord, or rather an angle, that is formed from the same points, so it can be AB, and those points form another angle at the circumference, those two angles are going to be equal because they're being formed by the same, we call it arc. So the arc AB forms both angles at the circumference. Therefore, they are going to be equal. And we're going to see how this is also relevant for cyclic quadrilaterals. Now, what are cyclic quadrilaterals? A cyclic quadrilateral is a quadrilateral whose vertices, which means all the corners, all lie on the circumference of a circle. So, for example, this here would be a cyclic quadrilateral. Like that. So this is a cyclic quadrilateral, and there are also some laws that govern these cyclic quadrilaterals. The first one being opposite angles are supplementary, which means if I have x over here and if I have y over here, then x plus y is equal to 180 degrees. Similarly, these two opposite ones would also be equal to 180 degrees, giving us a total of 360, which affirms that this is still a cyclic quadrilateral. Then we can also draw another cyclic quad in which we include an exterior angle. Now this law states that if we have an angle outside here, this exterior angle of a cyclic quadrilateral, this will be equal to the opposite interior, which is the y over here. This is because we know that x and its part over here, we can just name that maybe z. We know x and z should give us 180, but we also know z and y should also give us 180. Therefore, if z, let's say, is 100, that means x has to be 80, but that also means that y has to be 80. So, therefore, the exterior angle for cyclic quad is equal to the opposite interior. This is also similar to the exterior angle of a triangle being equal to the two opposite interior. So it's reminiscent of that one. And within Euclidean geometry, you have to apply all the properties of shapes that you have done up until now, especially the ones that include triangles. Then lastly, within a given cyclic quadrilateral, like this, you will have that the diagonals of a cyclic quadrilateral will be very similar to the law we just covered above, the one that says angles in the same segment. So again, if I name this A and if I name that point B, we can have that this angle here is equal to this angle here. Similarly, if this is C and that is D, we can have that this angle here is equal to that angle there. So if you can prove that all of this is true, then that means you are working with a cyclic quadrilateral, or just at least one pair of these would be fine. But you won't be proving much of anything within the NBTs, but you may be asked if it is as a sort of part of a identify the true statement type of question. But this is all on cyclic quadrilaterals.